Hi, we're on Unit 7, Lesson 5, using equations to solve for unknown angles. If you're not there, hit pause and get there. Let's figure out missing angles using equations. So, we're not really learning a whole lot new, we're just getting better at what we've done with a few extra twists. But warm-up says Tyler thinks this figure has enough information to figure out the values of A and B. Do you agree? Explain your reasoning. Go ahead, hit pause. Write something along the lines of, I agree because, or I disagree because. And I'll leave it up to you to figure that out. Do we have enough information to figure out the values of A and B? The tricky part is I'll give you a clue. No, we don't. Some of you might be saying, yeah, I just need a protractor, I need to measure. Well, kind of, sort of, but we're pretending we don't have protractors. We're not going to use a protractor at all today to solve for missing values. But so it kind of gave you a clue. No, we don't have enough information. Why don't we have enough information? So, when you're done filling that out, let's go on to 5.2. Hit pause. When you're done, hit unpause, and we'll move on. Remember, you're getting credit for doing all of this. I'll be making sure you've got some quality information written down. 5.2. What does it look like? Elena and Diego each wrote equations to represent these diagrams. For each diagram, decide which equation you agree with, and then solve it. You can assume the angles that look like right angles are indeed right angles. So that's important information, like I said before. Not always will they use that little tiny square to tell you. This is just telling us if it looks like a right angle, it's a right angle. So, here's our diagram. Oh, this is not good. Is this going to let me write? Oh, maybe that's why it's not working. Maybe because of my pen. Cross your fingers, cross your fingers. Oh, thank goodness. It wasn't working because the pen, my fancy Apple pen, the tip wasn't screwed on. So, this is what we're looking at. It looks like we want to find x, and I'm only saying that because these equations are x. So Elena wrote x equals 35. I disagree just by looking at it. It looks a lot bigger than 35. Stop doing that. How do I make that smaller again? This is no fun. It's just no fun. How do I... for crying out loud. Oh well, here we go. Shifted it to the left. I'm wasting your time and mine. So, x equals 35 does not make sense. But Diego, that does make sense. If I look here, there is a straight line. And Diego's saying if I take x, which is this angle, and add it to 35, I'll get that entire straight angle. So he is right. So x plus 35 equals 180. So how would I solve that? You got it. We're going to take 35 away from each side of the equal sign. We're making it balanced. You're going to like getting the habit of doing what I'm doing for 8th grade. And x is going to equal, you guessed it, 42. Haha. I'll let you figure it out from there. Number 2. Elena said 35 plus W plus 41 equals 180. Diego said 35 plus W equals 180. Diego, You are not correct. So I've got this, that's 35, plus the W, yep, plus the 41. I do agree. Altogether, that makes a 180. So I think if you want to solve this, step one, let's give ourselves some space to work with. Step one is, let's add that 35 and 41. Then you'll notice that is 76 plus W equals 180. Then you need to get rid of them, or get rid of the 76 from each side, just like the one above, and you'll be left with what W is. So go ahead and finish that one. Elena. First off, let's look at a picture. I see a W, I see a 35, and I see a W. Now remember, it said it looks like a 90-degree angle. It is. So I am noticing this right there is a 90-degree angle. With that being said, my first instinct was I see a W, I see a 35, and a W. Well, that's a W and a W. That's two W's right there, and a 35. But if we look at that, that does not equal 90. That's a much bigger angle. This angle is much bigger than 90. So Diego is incorrect this time. Elena is just saying, let's just focus on what we do know. We know this is a 90. So I have W plus 35, which is what she has, equals 90. And as you guessed it, I'm probably going to take off 35 from the 90. And you'll get W equals, I think, 55. Elena, number 4, said 2W plus 35 equals 90. Diego said W plus 35 equals 90. Well, let's see here. I think what they're saying is, it doesn't, I don't know why, but mine looks off. But I'm guessing this and this, that's a 90. So let's see let's see what's going on here. If you look here, let me use yellow. By yellow, I mean yellow. Oh, now it went back the way I wanted it. This thing has got a mind of its own. If you look at that, what we just made are vertical angles or opposite angles. So if that's 35, guess what? We know that that's 35. So we learned that a couple days ago. Now you should notice that I've got a W plus a 35 plus a W equaling 90. That means I've got two W's and a 35 equals 90. So Diego is no bueno. I have two W's plus 35 equals 90. So how am I going to solve that? Well, step one, if this whole thing is 90, if I get rid of the 35, I'll be left with the two W's. So I subtract 35 from each side, and now I have two W's equaling 55. Well, if two W's equals 55, then you can figure out what one W equals. Can you do that in your head? Two W's equal 50, that'd be 25. That's more than that. If you need a calculator, no big deal. Number 5, Elena. says W plus 148 equals 180. Diego, why even look at that? Let's look and see what's going on in this graph. So Elena's talking about W's. Diego's talking about X's. I do see at least two right angles, two 90-degree angles. So let's see here. Do you see this arc right here? We went all the way there. It's kind of weird, but either way, it says that's... No, I was going to say it says that's 148 degrees, but that's not true. That's a lot more than 148. I think it's just saying that's 148. So if that's 148, I see a straight line here. And I do know straight lines make 180 degrees. So 148 plus a little bit more, plus a W, would equal 180. So I'm thinking Elena is correct here. Trying to see if Diego's X plus 90, that was 90. He's almost correct, and I almost thought he was using vertical angle. For crying out loud, I almost think he's right too. Shenanigans. I know Elena's right, but let me see. Are you looking at what I'm looking at? Are you picking up? I think my eyes are playing tricks on me. If I look at X plus this 90, this is a 90 right here. This angle right here is a 90. X plus that 90, if I drew that, and this one's tricky. I've got a line here, and I've got a line here. Which means, first off, let me erase all that. And this right here, oh gosh, how many times do I have to click on it to get the color? That angle from that line to that line, and this one to this one, those are vertical angles. Those are opposite angles. Those are vertical. I think I am right. So wait a second. I'm looking at both of these, and both of them are correct, I think. Diego, he could be saying this X, let's call it, this X is right here, this angle, plus this 90-degree angle from here to here, X plus 90, that is the same amount as the opposite side, this 148. Altogether, this angle is vertical of that angle, which means X plus that 90 will equal to 148. So maybe I'm still missing something, but Elena and Diego are correct. They're both correct, unless it says in the instructions. Hey, they both could be correct. Elena, freeze your design. Well, technically I agree with both. It says, which one do you agree with? They're both correct here. Elena said W plus the 148 makes a straight line. I agree. That equals 180. So you can solve that one. You know how to do that, so solve that. But Diego, believe it or not, X plus that 90 does give you that 148 as well. So you can solve that. Pretty much just subtracting. Subtraction. All right. When you're done, hit unpause and let's move on. 5.3, calculate the measure. Find the unknown angle measures. Show your thinking. Organize it so it can be followed by others. Oh, darn you, I don't want to organize my thinking. All right. How could we do this? so that it is organized and can be followed by others. Well, you know what? We're going to make them happy. One way to make it organized is to just write equations. Guess what? Number one, if you haven't done it already, probably most of you are taking 180 minus 124, and that's good. If we want to organize our thinking, I've got W plus 124. I got W plus 124, and together that makes a straight line, this one right here. So that's going to equal 180. Now you're going to want to probably squeeze this in where it fits somewhere better, but either way, next step would be to take 180 minus 124, and you'll probably get an answer something along the lines of 56. So W equals 56. If I were to organize my thinking, let's do this so that you guys can see a good example. I would say W plus 124 equals 180. I'm going to subtract 124, subtract 124. Make that a better equal sign. That cancels out. I'm left with W equals 56. That way people can see my thinking, and we're good to go. Number 2, I see another straight line here. That means that 52 plus B plus 23 will equal 180. 52 plus B plus 23 equals 180. Step 1, let's add those two together. I could subtract them one at a time from 180, that's fine too, but those add pretty easily. I have 75 plus B equals 180, so people can see my thinking, and I'll let you finish it from there. You can hit pause and hit unpause when you're done. Number 3, here is a good vocabulary word. If you don't know this one yet, we need to write it down. Is it in our lesson summary? It's not bold there. Perpendicular, very, very useful mathematical term. Perpendicular means if I draw a line and another line that's perpendicular to it, it could either be like this, and in fact, you often see a symbol like this. I didn't draw it. Why does it keep going crooked? I did not do that. Oh, boy. My apologies. This is just wonderful. Yeah, go back. Okay. Perpendicular. This symbol here means a perpendicular. If you see something like line MN is perpendicular to QR, that means if those two lines touch, or where they touch, it's a 90-degree angle. So that's a 90. That's a 90. So when it says line L, here's line L, this one, and line M, this, what the heck? I have to throw this thing out the window. If only the window were open. Those two lines, when it says perpendicular, it means they form a perfect 90-degree angle. So you should be able to see there's a 90 here, a 90 here, a 90 here, and 90 here. If you draw 4 of those, you'll notice you make a square. Hence another reason why they're 90s. So if they are 90 degrees, we should notice, first off, let's fill in what we do know. This is oftentimes what I like to do. I remember taking some standardized tests like the SAT. If this is X, and this is X right here, I can see the vertical angle, that means that is also x. Notice this, that's wrong. This is not vertical. You'll notice those are not the same angles. This line goes, so it's not a straight line going through. So those aren't vertical angles. But this line's, on the other hand, these lines, this one goes straight through, this one goes straight through, which means if that's x, then that's x, because vertical angles are equal. With that being said, since we know M and L are perpendicular, that means we can see that this is x and 23 and another x. It's x plus 23 and another x. All that means it's 90 degrees. So that's like saying 2x's and a 23 is 90. This goes back to combining like terms. X plus x is 2x's. So if 2x's and 23 is 90, well, if I get rid of that 23, why did I write 12? I have no idea. I have 2x's equaling to, that's going to be 7, and that's going to be 6. So that's going to give you a tiny decimal, but that's all right. I'll let you finish it from there. And number 4, I got looking for a vertical angle. I see the 120. And I'm staring right at it. So I see that line and that line. If this is 120, or better yet, if this is 120, then opposite of that is this right here, which means M and that 66-degree angle and that M are 120. So that's like saying I have 2 M's and a 66. 1M, 2M, and a 66 equaling 120 because they're vertical angles, they're opposite angles. So I have 2M, whoops, I need to subtract 66 from each side first. I have 2M equals 120 minus 66. That's going to be 60 minus 6, which is 54. And you can finish the rest as usual. So that's about it. That was just some practice. This is a great problem right here, by the way, in the lesson summary. It's got a lot going on there, but it's saying 3 x's and a 90. You'll notice you get this angle. I'm going to go and cut it. You'll notice you have vertical angles right here. So the summary is saying I've got 3 x's and this 90. Well, that's all going to equal that 144, since this angle is going to be equal to that angle. So that's just another problem if you need to look at one. But either way, let's look at lesson 5, practice problems. What we got for time here? So far, so good. Segments AB, DC, and EC intersect at point C. Angle DCE measures 148 degrees. Find the value of x. Angle DCE. So it's saying D to C to E. is that angle from here to here is 148. So I've got an x right there, plus the 148, plus another x. All together, those make a straight line. So what's that going to be? 180. I'll let you finish it from there. Hit pause when you're done. Go ahead and let's move on to numero dos. Line L is perpendicular to line M. Find the value of x and w. Perpendicular means they make a 90 degree. So here, this line and this line together make a 90 degree angle. Whole lot of stuff going on here. Boom shakalaka. Who's got this one? This one's fantastic. Why are you changing colors? So, I do see 19 plus x plus w equal 90. 19 plus x plus w equals 90. That's too many variables. I can't figure out what x or w is. I do know that if I subtracted 90, make a better w. If I subtracted 19 from 9, I know what x plus w is, but that doesn't tell me. I do not know. It's not enough information to figure out what x or w is. So I'm looking here, this 138. Maybe that's obviously a piece of information I need to utilize. And if that's this angle is 138, then maybe I should be looking at vertical angles to help me get a piece of information. So if I draw the line straight across, if that's 138, then x plus 19 plus 90, since it's perpendicular, x plus 19 plus 90 will equal, all of that is opposite, it's vertical of all of that, 138. So that's going to equal 138. A lot going on there. Guess what? That'll tell us what x is. Then we can plug x back in to our original equation. Ooh, this is good. This is good stuff. So, first thing we got to do is combine like terms. Those are numbers. 90 plus 19 is going to be 109. So now I have x plus 109 equal to 138. And I subtract 109 from each side. And I would get x equals 139. I'm going to borrow 2, 18 minus 9 is 9. So I got x equals 29. So now I got to take this 29 and plug it in. Instead of x, I'm going to write 29. So now I have 19 plus 29 equals w. So I do 19 plus 29. And then subtract that. So if I erase all that, I can plug in 29 right here. So 19 plus 29 plus something is going to equal that 90. I'll let you finish that. So somewhere you're going to have to write a big old W equals something. Ooh, that was a wonderful problem. Just wonderful. And number 3, if you knew that two angles were complementary and were given the measure of one of those angles, would you be able to find out the measure of the other angle? Explain your reasoning. I'll let you answer that. Remember, two angles that are complementary. Doesn't mean they're complementing each other. And number 4, for in each inequality, decide whether the solution is represented by x is less than 4.5 or x is greater than 4.5. X is less or x is greater than 4.5. So, we got some other doozies there. What are we doing on time? 30. So no matter what, guys, they're telling us the answer is 4.5. And we kind of, we didn't skip over it. I just didn't take a whole day to teach you why or how this works. But I do know if you see this sign, you got x on this side right here. So I know it's going to be x, this sign, and on this side it's going to end up being 4.5 eventually. The only caveat is I've got a -6 times x, which means I'm going to have a -6x, which means I'm going to be dividing each side by a negative number. When we divide by negative numbers, we briefly did this for just a few minutes one day in class, but that means the sign switches. So normally the sign should just be facing that way and all life is good. But when I know I'm going to divide by a negative to get my answer, then I got to switch the sign. So same thing here. I know I'm eventually going to have to divide this side by a -8. Step 1 would be subtract 6. Subtract 6. So then I'm left with 6 minus 6 is nothing. I'm left with a -8x is greater than -30 minus 6 is a -36. Next step is divide each side by -8. These cancel, and I'm going to be left with x, and I have to switch it since I divided by a negative. And I'm going to get a positive 40.5. Same thing here. I can instantly see I'm going to have a -2 times x. So I'm going to have to switch it, and it's going to look like that. This is going to switch to that. Don't worry if you didn't get that because we skipped over it. But when you're solving inequalities, remember, just pretend they're equal signs. Do everything the same. The only caveat is if you ever multiply or divide by a negative, you have to switch the symbol. Number 5, a runner ran 2/3 of a 5-kilometer race in 21 minutes. They ran the entire race at a constant speed. How long did it take to run the entire race? How many minutes did it take to run 1 kilometer? The runner ran 2/3 of a 5-kilometer race in 21 minutes. Oh, we got a lot going on here. How many minutes did it take to run 1 kilometer? Well, we might want to first off figure out 2/3 of a 5-kilometer. 2/3 of means multiply, so let's switch that of 5. 2/3, so how far did he even run in 21 minutes? Well, 2/3 times 5, if I want, I can write it over 1. Multiplying fractions, we just do a numerator times a numerator, a denominator times a denominator. 2/3 of 5 is 10/3. I'm going to leave it like 10/3. That might make our life easier, but that's also 10 divided by 3 is 3 1/3. So 2/3 of a 5-kilometer race, that's 3 1/3 kilometers. Makes about sense. So he did that in 21 minutes. So how long did it take to do the entire race? Well, if he did 2/3 of a race in 21 minutes, then how long did it take them to do 3/3 of a race? 2/3 in 21 minutes. So technically I don't even need this yet. I think I'm going to need that for B, but if it took them 2/3 to do 21 minutes, the question is saying, if 2/3, I'm going to set up a table. Literally, I'm a math teacher, and even I use tables because they help me see stuff. If 2/3 equal 21 minutes, then what's 3/3, or what's 1? Right? What would 1 be? Because that's essentially, what would 1 race, not 2/3 of a race, what would 1 entire race be? And if 2/3 is 21, obviously 1 race is going to be longer than 21. And I'm looking at the relationships. I can turn a 2/3 into a 1 and do the same thing to the 21. And how do I turn a 2/3 into 1? Well, if I take 2/3 and divide it by 2/3, then guess what? Anything divided by itself is 1. And guess what? I'm going to have to do the same thing to 21. I'm going to have to divide it by 2/3. Whatever I do to one thing, if I do that. So 21 divided by 2/3 is the same as keep, change, flip. And I'm left with 21 times 3, which is 63, over, I can put that over 1 if I want to. 1 times 2 is just 2. I'm left with 63, or what's half of 63? Well, half of 60 is 30. Half of 3 is 1.5. So 31.5 minutes. A lot going on there. The trickiest part was figuring out I need to divide by 2/3. That's kind of like finding a unit rate. 21 minutes in 2/3 of a race. Well, how much in 1? Well, 21 divided by 2/3 will give me that per 1. And then it says, how many minutes did it take to run 1 kilometer? So 21 minutes, oh, that's 2/3 of a 5-kilometer race. So it was 21 minutes to run 10/3 kilometers. So we're going to have to do 21 divided by 10/3. And I ran out of room, and I'll leave that up to you. So I got a lot of circles going on, but I should kind of get rid of them so that I don't do anything. And I should probably start wrapping this up. I'm going to go ahead let's quickly, I'll leave number 6 up to you guys. But this last one, guys, if I look real fast, which are equal to the negative 36 plus 54, well, what am I going to do is I'm going to do negative 9 times 4 is a negative 36. Good. Negative 9 times a negative 6y is plus 54y. Good. A negative 9 times a negative 10 is plus 90. So A is not right. That negative times the negative should be positive. Here it says it's minus. So A is not equal to the expression. So let's not circle A. Negative 18 times 2 is a negative 36. So far, so good. Negative 18 times a negative 3 is positive 54. So far, so good. Negative 18 times a positive 5 is a negative 90. So that one works. So it goes negative 6 times 6, that's negative 30. Negative times a positive gives me a negative. This says it should be positive, so not A, not C. And I'll let you figure out the rest. But let's go ahead and call it wraps there for now. Go ahead and finish number 6 and 7 for homework, although 7's just about done. And actually number 5 has that last one, so it'll just be another minute or two. Keep up the good work. Have a fantastic weekend. Keep it real. Keep it fake. Keep it really fake. Yeah, I guess that's it for now. Peace.